Hello, this is Mrs. Ross, and I'm going to work through the 2.4 motion in a plane test review. Okay, this is the first question. The components of vector A are AX is 6.1 and AY is negative 8.6. The angle is measured counterclockwise. So if I have a clock normally goes this way, I'm going to measure this way, okay, from the x-axis. So let me go ahead and get my axes drawn. There's my x and y, and then let's fill in what we know. So I know that AX is equal to 6.1, and I know that AY is equal to negative 8.6 or something. So this is going to be here. And what I did was I found this theta. Now keep in mind this is clockwise, this is not what they've asked for, but I said, all right, the tangent, if this is 6.1 and this is 8.6, the tangent of theta is going to be 8.6 over 6.1. Tangent inverse of 8.6 over 6.1 is equal to 54.6 degrees, or 55 degrees. So if this is 55 degrees, they still don't want me to measure it from there. They want me to measure it from the x-axis counterclockwise, so from here to here. So they want to know what this angle is. So I had to take 180 and I subtracted 55 and I got 125, which is E. All right, number 2. So what I ascertained about number 2 is there's a problem. Where's my thing? This is not supposed to be here. BX is supposed to be 15.2. So that's an issue. If BX is 15.2, you can go ahead and set up a proportion where you have AX over BX is equal to AY over BY, since the only difference between A and B is a scalar multiple. So what I have is, let's see, 7.6 over... No, that's not how I set it up. I made this, well, it should still work. So let's do 15.2 is equal to AY, which is 9.2 over whatever BY is going to be. That's what we're solving for right here. So I cross multiplied and I got BY is equal to 18.4, which is this answer right here. Okay. So we're given vectors B and C, and it says it's multiplied by a scalar of 921.5. Multiplying a vector times a scalar does not change the angle at which the vector, or the direction of the vector. It doesn't change the angle at all. So because this angle is 33, it's still 33. Kind of a tricky question. Okay. So let's, oh, this is not the one I have. Oh, here we go. Okay, number 4. Okay. So this is what I have for this one. I went ahead and I dropped this. So I have BY and BX. And I dropped this one. So I have CY and CX. Okay. I subtracted 90 or 22 from 90 and I got 68 here, because I'm going to be using that for my, so this is 5.6 and this is 4.8. So, okay, so I found BX and BY. The cosine of 33 is equal to BX over 5.6. So BX is equal to 5.6 times the cosine of 33, which is going to be negative 4.69 because it's in the negative direction on the x-axis, okay? And then we found sine of 33 is equal to BY over 5.6. This is 5.6 times the sine of 33, which is negative 3.05, because it's also in the negative direction, okay? Then I did the same thing. Let me change colors. I did the same thing for C. So, cosine of 68 degrees is equal to CX over 4.8. So I have CX is equal to 4.8 times cosine of 68 degrees, which I got 1.8. And that's positive. Okay. And then the sine of 68 is going to give us CY, which is CY is equal to 4.8 sine of 68, which is equal to, I got negative 4.5 because it's a negative in the negative direction. So now I have all of these numbers. I'm going to change my colors again. And what they're asking me to do is they're asking me to do B plus C. And to do that, I take my x's. I'll take bx plus cx, comma, by plus cy. So bx is, I put negative 4.7 plus 1.8, and by is negative 3.1 plus negative 4.5. Okay, and I got as my resultant, or sum, I got negative 2.9 and negative 7.6. So let's see which quadrant that would be in. So if this is 1, 2, 3, 4, I want negative x, which is going to be one of these two, and then I want negative y, which is going to be this one. So the quadrant is going to be 3. Okay. In his famous race, a hare runs for a while, takes a nap, and then resumes running until he reaches the finish line. His total displacement from start to finish is 5 meters east and 12 meters north. The hare's total race time, including the time of napping, is 28 minutes. What's his average speed in meters per minute? Okay, so we're given 5 meters east and 12 meters north. I'm going to draw that out here in a minute. And then I'm given that the time is 28 minutes. I'm looking for speed in meters per minute. All right, let me change colors. Okay. So what I have is here's my 5 meters east, here's my 12 meters north, and this is a Pythagorean triple, 5, 12, 13. So I know, and you can do the Pythagorean theorem and double check me if you want to, that's fine. But I know that average speed is going to be distance over time. So I have 13 meters at 28 minutes, and when I divide that out, I get 0.46 meters per minute, which is B. I just lost my cursor. There we go. All right. What are the components of vector with magnitude 4 and direction of negative 112? So what I did was I am looking for, I have to not have this color because I cannot see it. Okay. I need AX and AY. I just called this vector A. You can call it whatever you want. And so when I graphed this, the direction of negative 112, I said, is going to be this way. So it's going to be in this quadrant. Okay, so this is 112, which makes this 68. Here's AY, here's AX. So I know that it's going to be a negative and a negative, so that tosses that one. So let's see, if I do the sine of 68, which is opposite over hypotenuse, my hypotenuse is 4. So I'll get AY over 4. And if I do the cosine of 68, I'll do AX over 4. And I get that AY is equal to negative 3.71 and AX is equal to negative 1.49. So this should be X and Y. This is it. Okay. Wait a minute. Here we go. Okay. All right. So let's see what I did here. These are the same vectors as are in number 4. So I already have my, let me write this down up here. B is negative 4.7, negative 3.1, and C is 1.8 and negative 4.5. Okay, and I got that from number 4. And what I'm looking for is I'm subtracting. So I want to do B minus C, which looks like what? Like this. Okay. Which is actually B plus a negative C, and you'll see that here in just a second. So I have negative 4.7 minus 1.8, and then negative 3.1 minus negative 4.5. Okay, so I get negative 6.5 and 1.4 as my components. Sorry, the word left. So let's see where exactly that would be. So negative 6.5 would be here maybe, and positive 1.4 would be here. So this is going to be D, right? And I'm looking for, it says measured counterclockwise from the x-axis. So that would be this right here. And what I did was I found, since this is 1.4 and this is 6.5, I found this, which is 12 degrees. And the way I did that was I said tangent theta is equal to 1.4 over 6.5, and I did tangent inverse of 1.4 over 6.5, and I got 12 degrees. But they don't want that. They want this. So I did 180 minus 12, and I got 168, which is my answer. Okay. Aha. Okay. So I will probably be able to do this one. This is number 8. We're about halfway through, and then I'll have to do another video for the rest of them. So just kind of a heads up. So a step of science investigation, it tells you to walk 3 meters in a straight line and then turn 60. So I started to draw this and it was bad. I was like, okay, if I turn 60 degrees and I go 3 meters here and then I turn 60 degrees, you know, trying to figure that out. But what happens is this is actually something that we learn in 7th grade math. I'm not sure if they even covered it in your lesson, but it says number of sides of a polygon equals the total angles divided by the exterior. So we know the exterior angle is going to be 60. We know the total is 360 because all of the exterior angles add up to 360. So we get 6 sides, which is your regular hexagon. I'm going to go ahead and stop there, and I'll start the next video on number 9. Okay.